Okay, it's work. Yeah. Hello. I'm glad to be here. So I will lead today the panel, and we will explore a few questions. It will be a technical talk, but please feel comfortable not to follow up on everything. Okay, so it's fully okay, and I have a couple of rules, guys. I will address you by name. I will ask a question, address you by name, and please try to kind of be in 3-4 minutes for the answer. So the first question will be related to zero-knowledge technology in general, and what zero-knowledge scheme we should pick up for the kaspa layer 1. And please, Simka, you can take it.
Okay, thank you very much for inviting me. Actually, I've been talking with kaspa for at least 4 years. But it's very impressive that you have been engaged in this plan of adopting CK, your layer 1, and I was so interested in how a blockchain, besides Ethereum, right, are interested in making a CK proof and complementary ingredients for layer 1 as a POW ingredients. So, as we all know, that zero-knowledge proof is a technology that can prove the result without a redo the calculation, right? And this is usually used in increase the capacity of layer 1 blockchains. But because we already have kind of successful example of Israel, right? They have quite a lot of layer 2s that working kind of successful. So that means we can learn from other mistakes. Right, there are lots of mistakes there. And I think the most significant mistakes that from Ethereum is that it's very hard to actually design a technology that can transfer messages from different layer 2s. Just as in your last talk, right? You have some kind of interplay design for transfer messages from different layer 2s and using your layer 1s as a native chain. And the reason for this difficulty and these mistakes that the Ethereum has made is because most of the zero-knowledge proofs accepts the state proof as a single Merkle tree root proof. Right? That means you have to assign the order in the sequence to make sure which Merkle root comes in first. Right? So that means if I reorder the transactions, single proof of the first transaction might become illegal or invalid if we reorder the first with the second. So I think that will be a very good target topic for kaspa to think about how to actually we can reorder the zero-knowledge transactions without redo the zero-knowledge proof with significant ordering of the Merkle root. So that's one problem. And the second problem that we can learn from Ethereum's mistake of not providing a very standard specification of how layer 2 should be designed. This gives lots of examples. There are so many zero-knowledge schemas and so many different schemas of transferring information between layer 1 and layer 2. We all know that you have a layer 1 that's very easy to design a schema so that you can send out information from layer 1 with zero-knowledge proof, with your specification. It's hard to actually receive information from layer 2s, and if you have an open specification like Ethereum, then all these different layer 2s will diverge, right? But if you start from scratch again and learn from their mistakes, it's a good chance so that you design a schema, slightly more narrow specification so that you can constrain what your imaginary layer 2 looks like. Yeah, that's two topics that I think.
Can you please address the topic of zero knowledge hash functions? Because like it's an important topic for us. It's related to sequencing commitments that Michael have presented previously, and how to pick the winners there, and related to opcodes, like is it possible in general to implement ZK verification DSL style?
Okay, so I guess because recently the ZK technology stack has moved so fast. We have Binance, we have GKR some check, and we know that projects like Polyhedra already can do hash functions in GPL, some check, within very small amount of seconds. So I don't think it's very tricky now to pick a hash function, because even you do KCAC, it can be done several megabytes within milliseconds using Binance or Composability or GKR. So I guess we can pick any hash function that you think is strong enough, and let the ZK engineers to pick the technology that can moving fast on your hash function. It's not like last year, and these days it's no longer a very critical choice.
Yeah, but a lot of ZK-friendly hash functions, they finite field dependent, and once you pick up the one, you kind of either introduce different fields or...
You can just pick KCAC. It's a bitwise hash function.
Blake?
Blake is, I'm not sure what's the current benchmark for Blake. Blake should be okay. I mean, once you have aggregation technologies and you can aggregate binary proof with composability or star proof, then the hash function. So the reason you need hash function is mainly for the multi-key proof, right? Yeah, so it should be okay. I guess, I mean, I'm not an expert on that, I guess.
Thank you. So we go to our next question. So we are aware about liquidity fragmentation problems that layer L2s brings to the Ethereum world, but from the perspective of more core team, when we try to think about this liquidity defragmentation, we reach to the world of state management maybe, and unification of state management. So my question is what is the best way to think about it and to model it, and the best direction to go? And please, Hans, you can handle this question, please.
Yeah, okay, hello, does everybody hear me? I think what you said before, Sinka, is very important for L2s, that you have some kind of agreement how to model state, to have some kind of agreement of how all these different rollups interact with each other. And I usually like to look at DLTs not necessarily as distributed protocols, but essentially as virtual countries, right? You have like a country with a lot of virtual citizens. Every user is a virtual citizen, and you want them to be able to interact with each other as efficiently as possible. And if you imagine a country where you don't have any agreement on what language you speak, on what side of the street you drive, on how you interact with each other, this becomes very hard. Of course, it's very nice if everybody can build and do whatever they want, but if everybody drives on different sides of the road, you start to collide and you kind of like run into each other, and things just don't work very smoothly if you don't have this kind of social consensus layer that allows you to interact with each other in a seamless way. So I think the best way to actually address this problem is to define some kind of standard where you say, okay, we model state in a specific way. And Jonathan earlier, for example, talked about Move, Zui and Aptos. They have this asset-based model where essentially state is modeled as an object, and you have interacting objects, right? Like you have things like that work like in the real world, and you can attach logic to these objects. And I think that's a very elegant design, and it's a very nice design also because you can address state individually. It's not just some big blob. So if you want to move one state from one economic island or logic zone to the other one, then you can actually address that specific object, take it out of your state, and put it on the other side, on the other rollup, and move it like seamlessly between these zones. So I think the best answer for preventing this fragmentation is to actually create a layer of social consensus around how a state is managed and how it's organized and how all of these contracts talk to each other.
Michael,
Just a question for our hands. So not necessarily atomically composable all over, right?
Atomic composability is, I think, a topic that is somewhat orthogonal to this entire decision, right? Because, I mean, just because you know how you model your state and how you model objects and how you associate, how is logic associated to these objects, it doesn't necessarily say anything about if you do atomic composability or not. I mean, it's an orthogonal topic, and I think it's also one that is worth discussing, right? Because there's certain trade-offs, like in specific, when Jonathan earlier mentioned, for example, the Zui static parallelism versus the Aptos more dynamic one, and I think if you want to have a sharded system like this, the static version is definitely better. But yeah, I mean, that is kind of orthogonal. That doesn't really have anything to do.
As far as I know, we have examples of like this kind of state modeling perspective on top of UTXO-based systems, right?
Yeah, I mean,
so we have like good examples from the industry how it can be done.
Ultimately, this asset-based model is really an extension of the UTXO model, and the UTXO model you have essentially states identifiable. Each balance of coins is its own individual state that you can spend in parallel and address individually. And what the asset-based model or this object-based model that Move brings to the table does is essentially just introduces a persistent ID that ties a sequence of state changes of a certain object together and just says, okay, all these sequence of state changes of UTXO transactions is one object, and I can address that object through a persistent ID that doesn't disappear after each transaction. Right? It's a natural extension of the model that kaspa essentially uses already. So I think it would lead itself very nicely to this design.
So you mean baking asset management into L1?
No, not necessarily.
So how would you...
Creating some kind of social consensus around how the L2 stores its state.
Right, but how would you access the same assets from multiple rollups? You would need atomic composability. Assuming the assets are managed somewhere, you would need everyone to be able to interact with them synchronously, right?
Not necessarily. I mean, you can also do this in individual transactions. Like for example, I'm the proponent of like DLTs being tools for people to, or for humans to reach social consensus, right? So I think this vision of having each smart contract being its own rollup is not necessarily the best option, because I think you want people to have some kind of agreement, like what language to use, how to interact with each other, and these kind of things. So I'm very much in favor of creating larger islands of economic activity with general purpose execution environments, right? And then you can just move your assets from one island to the other, but you don't need to necessarily atomically do that in a single transaction. It's like I don't need to, as a human, for example, be able to buy a bread in Japan and sell it in Berlin, and then like move the remainder to my grandma in the United States or something. I can definitely constrain my economic activity to some kind of local cluster, and if I want to move clusters, that should definitely be possible. I should be able to move my assets from island A to island B, but I don't necessarily need to do all these interactions atomically between them.
Yeah, so the movement of the asset between islands would be like an asynchronous operation. Yes. But
within an island, you would still have composability for all the DeFi applications and everything that you need to do.
Kind of assumes there's an alignment between the domain, the business domain, maybe DeFi, gaming, and the infrastructure technology, which I would think is questionable.
And why the social consensus part is so important? Like, what is the problematics? Just, decide that we are taking this direction. It fits very naturally on top of UTXO-based system, and as far as I know, this is maybe the best solution known for now. Yeah. Of
which one?
Like the state management on top of like object-based.
So atomic composability all over?
Yeah, like but you have this like meta layer of assets, okay, that everyone kind of agrees upon. But why it should be particularly tied to the social consensus? You mean like we as a community and miners and developers should agree to take this direction?
I think so, yeah. And I think the reason is what we are just discussing, like the economic fragmentation that we have in Ethereum. And it's just the reason because everybody has their own ideas how to do things, right? As soon as you have different projects, different roll-ups, you have different economic incentives. There's not even an incentive for people to agree. Like Jonathan earlier said, you can definitely see these roll-ups as B2B services, and they try to capture as many businesses and as many users as possible, and eventually even steal these things from each other. And to just hope for the best, for them to get along, to come up with a good solution, and to just build a system where everybody agrees, I think that's unlikely to happen. And I think it would be nice to have a system where you kind of, I don't know, I would maybe say force users to agree, but in a way, yes, force users to agree to reach some social consensus to build a system where everybody can seamlessly interact with everybody else.
Michael?
Yeah, I would argue that I would also like state scalability, meaning sharding, also within some specific business domain. Like DeFi is too large. I don't know how to separate these islands into small enough units, because if there's only like 3 of them, my theoretician side doesn't see that as significant. So I would still want us to support atomic composability between logic zones, so that we can scale their state, for instance. And yeah, so
thank you. So it's very natural for us to switch to the next question related to atomic composability in general. So let me throw a couple of points that I personally have. So first point.
Can you answer?
Yeah.
Can you answer as well?
Restate. I'm kind of very agree with Hans in this direction of state management through a meta layer of unified layer of assets. Okay, that we define directly on layer 1. In this way or another, it's, you know, we have different options how to do it, we just need to decide. So this is my take on it. I think that
that's part of the argument. But
yeah.
Okay.
I just want to say again, this does not say anything about atomic composability. It's just establishing a common language so the different smart contracts can understand each other, right?
Right, but if you have atomic composability across technologies, so why the need for islands?
The islands is just also, I guess, maybe an easier way for the implementation complexity, because if you want to have this protocol that you combine proofs, right? You said earlier you have this optimistic assumptions, then you're actually starting to mix concepts of zero-knowledge rollups with optimistic rollups to some degree, right? You can do this, and definitely think it's possible, but it sounds like a pretty,
Optimistic. Okay, we'll take it.
Yeah, but you need to make some assumptions that you get access to the data, for example, that you need for execution, otherwise you cannot continue your own chain, right? So this sounds like it might introduce a lot of complexity. And so for the beginning, especially for rolling out smart contracts relatively fast, it might be easier to commit to some kind of non or async form of communication, maybe add synchronous communication later on as an update.
Okay, so let's move to the next question related to, I want to ask related in general reatomic composability. And I think for me, the atomic composability, when I try to translate it to more like familiar day-to-day world of what it means for regular people, I'm usually jump to the risk-free system. Okay, when I don't have atomic composability, I need some intermediary, some insurance companies that will secure the transactions, the 2-3-step transaction, and so my fee will be larger. Okay, and when I have atomic composability, I can easily model supply chain use case and a bunch of other financial use cases. But in the same time, when I observe the, for example, Ethereum overall transactions, or overall transactions in general in the blockchain space, okay, I see that like 2/3 of the transactions, they are fully parallel. They don't need atomic composability. It's just ERC kind of financial activities, and I won't send just money or tokens from one account to another. So, and now the engineering-wise, to properly model this concept is kind of difficult problem, right? So I asked myself, and I ask you, like, what, like, how you see it in time? Like, should we jump right now to have it, maybe to delay it, or like, what you take on it?
So
You can start, yeah.
So it seems like a tendency between starting faster, starting somewhere, and the question whether perhaps starting at the wrong point in the design space might be lethal. That's like, to me, that's the question. Obviously, it makes sense to start with the most simple system to get rolling. But if perhaps we make the wrong choice, it might be too hard to go
We will
back.
suffer forever.
Yeah. So the details of the tech complexities are still being figured out, I think. So it's getting more and more clear what we would be able to assess soon what the effort is, I think, and make a more wise decision, but it's not an easy one. We need some more profits, maybe. You know one?
It's like it also like feels that our like core knowledge related to DAG-oriented algos and systems in general kind of plays well with to address this kind of problem, right? Like DAGs naturally evolve there, like when you start thinking about how to model this stuff.
Yeah, that's where I carry some HPC distributed computing knowledge, the computational DAG. We find DAGs everywhere, but yeah, I lean more towards trying to make a complete design, but it's also, we are starting with something already with Crescendo, so maybe that's also an argument.
Hans, what is your take on atomic composability?
Well, as I said, I think it complicates, it's definitely complicates things. It would be nice to have, but if we're able to, for example, identify things that are somewhat orthogonal to this design that don't really interfere with any like downstream decisions about how you ultimately like manage these kind of interactions, I think it makes sense to maybe start with something that doesn't have atomic composability out of the box and then see how things progress and eventually think about ways to bring this on later on. But there's another thing I wanted to say to what you said earlier. You said if you don't have atomic composability, you need like insurance providers and stuff like that to enable the interactions. But what you're really doing is you're essentially making, like, if you introduce atomic composabilities, you're making the L1 the insurance provider, because suddenly it's no longer predictable how the throughput and the load distributes throughout the system. It could be that everybody decides to call the same smart contract once, and suddenly you have a huge congestion that affects the entire system, where suddenly everybody needs to wait for this one island to process all the load. Whereas in a system where you don't have atomic composability, you have complete predictability about the throughput requirements of each island. You cannot explode in like implementation and execution complexity. So this is very nuanced and big topic that needs a lot of consideration. So for the beginning, if you don't have answers to all these complicated questions, I think it makes sense to deliver something that works so people can start building their user bases and building their systems and then improve later on.
We must find answers.
At least at research level. Yeah, right. So, what would be our like short-term goals for like after Crescendo? What we can deliver to the community in the next year? What we take on this? Related to generic programmable smart contracts, zero knowledge scheme, opcode in our scripting language, our hash functions, what it can be in the short term.
I think we can kind of not leverage, but like we know that the lack of zero knowledge means the system is a little less, it needs more trust. So we can use this time to think about creative degen, smart contract activities maybe. Creating use cases which illustrate the frequency of the system. Having like smart contracts that form a game or some kind of bet and real-time events. Using the speed and frequency and the expressiveness for use cases which are not so critical, where you don't really need bridging of tasks and full trustless systems. You can have some trust. So that would be like a nice spot to work on short term.
Yep. Guys, our time is off, so thank you everyone to listen to our talk. Please relate to this talk as more or less opinions and not final decisions. And we encourage you to reach out to our Discord and Kaspa research website. We collaborate there, we express our ideas, we explain all the pros and cons, how we see it, and please follow up. Thank you very much. Thank you guys for joining.
Thank you.